Hello, welcome, and thanks for stopping by. Today we're going to discuss the basics on how refining jeweler's scrap is done. After watching this video, you can decide if the process is something you want to tackle yourself. It's going to be a little longer video, but this is necessary to show the process and explain it clearly and accurately. Please note, this is not a video for scrappers, stackers, miners, or prospectors. It does not at all work for gold. This is sterling only, and it does not include the various methods for dealing with alloys beyond what a typical silversmith would be working with. This will describe the process in its simplest form on how jewelers can turn their scrap into 3/9 fine silver. Please understand this is not to be used for plated or filled items or scrap containing lead, brass, nickel, any other alloys that are not found in higher quality solid sterling jewelry scrap. Before the comments blow up, yes, there are other methods and processes. To keep this video shorter, we're going to show one process. Other processes will be available in future videos. If you're familiar with refining, I'm going to use the copper displacement method for brevity and simplicity for the noob. The sodium hydroxide sugar method will be in a future video. Of course, I've got to recommend that you pay someone to do this that knows what they're doing and understands how to deal with problems if they arise. Towards the end of the video, we'll describe the acids used and how to obtain them. Okay, before we get started, if you find this video helpful, you get something from it, you were enlightened, you enjoyed it, please like and subscribe. Content creators put hours of effort into these videos. You can show your appreciation by subscribing and watching the video all the way through. If I miss something or you have a question, please drop a comment. Okay, let's start with some safety and some warnings. Sorry, absolutely required. Refining is no joke. It can be a dangerous process. If you are the type of person to ignore warnings and think you are God's gift, do not even try it. Turn the video off now. Go watch something else. This video is for informational purposes only and for the education, entertainment, and enlightenment of the viewers. We do not accept any responsibility for anything you attempt. Let's start with acids. The acids we're going to be using will cause severe burns, damage to flesh, and it can ruin your tools. Always add acids to water, never the other way around. Apron, gloves, and face shields should always be worn. We're going to be creating some pretty obnoxious fumes. They're called nitrogen monoxide. We also call this red death. This entire process needs to be done outside upwind or in an approved fume hood. Don't try it in your garage. I don't care if the door is open or not, or inside of a building. The fumes are not only toxic, but if they get around anything steel, like your tools, I promise they will instantly rust. Thirdly, keep a baking soda water bucket nearby, maybe a cup of baking soda per gallon of water, right at your feet. If anything spills, immediately pour the baking soda water onto it to neutralize the acid and keep pouring it on until the fizzing stops. Do not try to clean anything up until you've neutralized the acid. Next up, gloves are required, but do not wear nitrile gloves. That photo is an actual nitrile glove with acid poured on it. That's how they react. You want to use butyl, vinyl, or neoprene gloves. You can get them anywhere you can get nitrile gloves, so no problem there. The next thing, glass only. Never do any of this in metal containers. I don't recommend plastic either because there's so many different kinds of plastic. Something is going to react. You want a glass container that is 3 to 4 times larger than you need. This is going to bubble and boil, and we're going to be rinsing, and we need extra space. If you've got 200 grams of scrap, you want an 800 milliliter container. So just take the number of grams you're going to refine, multiply it by 4, and you need at least that many milliliters in your container. You only want to stir this stuff with a glass rod. You can get those on Amazon or numerous other places. And something the picture does not show is what we call a watch glass or curved glass or ceramic cover. You see how this is curved a little bit on one side? When we cover the container, as the water tries to evaporate or the fumes are coming up through, it'll collect on the glass and it will drip back down in, so we don't have to keep adding water. And because you're going to be doing this outside, this cover will also provide a little protection against leaves, dust, whatever might be flying around your yard. And you have your glass stir rod. It doesn't have to be a laboratory beaker. You can get them fairly cheap on Amazon, but you could use a mason jar or any other wide mouth. You don't want to use a small mouth jar. So that's the story on glass containers. Okay, that wraps up the warnings. I may add a few more in post-processing, but I think that'll cover it for now. Let's talk real quick about what we're actually doing here. What is refining? Simply put, it's separating a metal from one or more other materials, rock, other metals, plastics, gems, things like that. Typically, our sterling contains number 1, silver, and that's what we want back. It'll have copper in it because sterling is 7.5% copper. We don't want that back. We don't want the zinc or tin from any solder, and if you have some clasps with steel springs in them or pins, we want to get rid of those also. The process is fairly simple. The first thing we're going to do is dissolve the silver and a few other metals into liquid, literally. After we dissolve, there's some tricks to remove things like lead and other alloys. Those are going to be beyond the scope of this video. I'm happy to discuss these further, but I'm going to assume in this video that you have fairly clean scrap that doesn't include weird metals. The next thing we're going to do is filter it. Any organics or gems or non-silver stuff will not dissolve. It'll settle down to the bottom, and we're going to filter it. We're going to get rid of all that. We don't want it back in our pure silver. The next step is to precipitate, which simply means the liquid silver is going to turn into powder silver metal. And that's what we want. Then we're going to wash and decant and rinse and get rid of all the acids and some other things. And then we're going to dry it. And then, of course, we'll melt it into either casting grains or ingots, or you could leave it in powder form. I don't recommend that because if you knock your silver powder container onto the floor, you'll play hell trying to sweep it up and re-refine it to get rid of all the dirt and stuff. Okay, let's get into the process. First thing we want to do is weigh out what kind of silver we've got to refine. We will need this information later. Oops. Okay, get out of there. Now, I'm also going to save out a little bit of this scrap, and it will be obvious why later in the video. But I'd like to take, we're about 2.5 ounces of silver here. I think I'm going to save out maybe that ring, a couple of these bands. And now we're down to about 2.1. That should be good. So I don't have to go through this again. I'm going to write it down. 2.157 ounces, which in grams is 67.10 grams. I have the sterling that I'm going to save out for later in the process, and we're good to go there. The next thing we must do is, with a magnet, make sure there's no steel in here. I prefer to use rare earth magnets. They're very strong, and they will find the teeniest pieces of silver. So I'm going to go through this and see if anything sticks to the magnet. Way down at the bottom, and I think we're good. The magnet is clear. Okay. Now we're going to bring this out to the bench, and we're going to burn off any nasty materials real quick. Let's go to the bench. All right, out at the bench. Nothing rocket science about this step. I'm going to take an old crucible that I wouldn't use for anything else. We'll pour our scrap into it. And what we're going to do is just get this nice and hot. It totally doesn't matter if we melt it. We're refining anyway. I'm going to use a fairly large flame. If I can get my torch lit. Doesn't matter what kind of flame. And we're going to start heating. I'd like to see just a little bit of discoloration to tell me that I got it hot enough. And then after we heat that side, we'll stir things around. I'm using my titanium solder pick for this. A little bit of melt there, no problem. I see a little bit of bluish green flame. That's the solder, the zinc and the solder on a couple of the pieces. We're getting some discoloration. And I think we're about good. What we're trying to do here is burn off any oils, skin cells, any other gack that might have been on these parts. Organics kind of tend to make a mess of the refining process, and this is just going to make our life a little bit easier. So we're going to let this cool. Ooh, yeah, very hot. Bring it back in and we'll continue from there. Okay. We've let the sterling scrap cool. I put it in my beaker. And now we're going to start really getting into things. Excuse me. For the next step, let's talk about how much acid we're going to need. If you had pure silver, not sterling, no copper, just pure silver, it will take about roughly 1.15 milliliters of acid per gram of pure silver to dissolve it. If you're working with sterling, Because of the copper, we need a little bit more acid per gram of sterling, so about 1.3. If you Google this up, you'll get 10 different answers, but I find these numbers work pretty good. So, we are working with sterling today, so we're going to take the 1.3 milliliters, multiply it by our scrap weight, which was 67.1 grams. That tells us we need 87.23 milliliters of acid. No, you do not need to measure all the way down to the right side of the decimal point. Round down, because we always want to use up all of our acid and have a little bit of sterling left. Okay, that's very important. And for the refining process, the chemical process, we want the same amount of distilled water as we are using acid. So 87 milliliters of acid and 87 milliliters of distilled water. Just like everything else we do in metalsmithing, we use distilled water, so all those weird chemicals in tap water don't pollute our stuff. I will remind you again, and probably 5 more times, we always add our acid to water. We do not add water to the acid. Okay, so I'm going to write down on my little notepad that I need 87 milliliters of the acid and 87 milliliters of water. So what I have is my sterling scrap in my beaker. I have 87 milliliters of distilled water, and I have 87 milliliters of acid. I have my gloves on. I have my face shield on. And I absolutely recommend you do also. I'm going to go ahead and put the water in. That doesn't hurt anything, but I'm going to wait till I get outside to add the acid because it will instantly start generating nitrogen monoxide. Now we're outside. I am far away from anywhere people may be, or animals may be, or it could get knocked over, or stuff fall in it. I have my watch glass or my container cover, my acid, and my sterling with water. Something that's important to mention here, if you're going to refine a larger quantity of silver, 300, 400 grams, you're going to want to add half the acid and water at first, and then add the other half a couple hours later. That's so it doesn't boil over, make a mess. Something else I do is I always leave my container in a tub. If it does for some reason break or get knocked over, you could lose your silver into the dirt and you would never get it back. So keep a tub, and then we'll make this happen. Okay, so we've got our acid and water mixture. I'm going to take our acid, pour it in, and immediately put the cover on it. You can see that there are a few bubbles already forming. And in just a few minutes, we're going to have a red cloud coming out of this. So I will film that from a distance in just a few minutes. The reaction has started. It's bubbling and boiling and generating nitrogen monoxide. Fairly breezy day today, so it's not overflowing the cover. Remember, you want to stay upwind of this. Something else I'll mention, if it's a warm day, the reaction will begin and complete much faster than on a cold day. So if you're in the middle of the snow, it might take an extra day to dissolve all this. So what we'll do is we'll let this go until all the fizzing and bubbling and the nitrogen monoxide stops. Let's take a little bit of a tangent for the nerds now, or the curious. If you have a chemistry background, you'll understand this. If you don't have a chemistry background, don't worry about it. We're just here for the nerds for a couple of minutes. What we're doing with the silver in the scrap is we're mixing the silver with acid, and the result of that is going to be silver nitrate, clear liquid. We're going to make nitrogen monoxide in a gas. That's what we call red death. And we're going to have a little residual water. For the copper in the sterling, we're mixing copper and acid, and that is going to create copper nitrate, which is a beautiful blue clear liquid. We again will create nitrogen monoxide and have some residual water. When we're done dissolving everything, our liquid is going to be blue, and that's totally okay. Well, we're back at the bench. The refining is in progress. The reaction is taking place. That's going to take anywhere from a couple few hours to overnight, depending on temperature and how much silver you're refining. I typically let it go overnight, just so I'm not out there looking at it. You know, the watch pot never boils. So, another reminder, for part 2, make sure you subscribe and click the bell so you know when part 2 comes out. Much more information in part 2. And we'll cover the rest of the refining process. We'll melt some casting grains or ingots, whatever we feel like. Maybe drop a comment. Let me know if you want ingots or casting grains. We'll talk about what acids you need to get, how to get them, what strength and category of the acid. And I'll do up a little spreadsheet. We'll weigh everything out, and we'll look at the total costs for this refine. That's an important one for people. There are some costs involved. So, hope to see you in part 2. Should just be a couple few days. And with that, be well, be creative, and we'll see you next time.